Welcome to a second lesson on converting base 10 numbers to different bases. In this method, we'll be using a calculator to convert to different bases. Let's begin by considering the number 1432 in different bases. In base 10, the base we're used to working with, we know the 1 represents 1/1000, we know the 4 represents 4 hundreds, we know the 3 represents 3 tens, and the 2 represents 2 ones, giving us our number in base 10 of 1432. Another way to represent the place values in base 10 would be to take our base 10 and start with 10 to the 0, which would give us the ones, and then move to the left by adding 1 to the exponent each time. 10 to the first would be the tens place value, 10 to the second would be the hundreds, 10 to the third would be the thousands, and so on. So if we look at this same number in a different base, the place values change. For base 5, notice how we'd start with 5 to the 0 with the ones, but then we'd have 5 to the first or the fives, followed by 5 to the second or the 25's place value, then 5 to the thirds or 125's place value, and so on. If we change to base 6, notice how again the place values change. So if we wanted to write these numbers in base 5 and 6 in base 10, the 1 now represents 1/125, the 4 represents 4 25's, the 3 represents 3 5's, and the 2 represents 2 1's, giving us 242 in base 10. For 1432 base 6, notice how this would be equal to 380 in base 10. But the main goal in this lesson is to start with a number in base 10 and write it using a different base. To do this, we'll be using a calculator method where number 1 will find the highest power of the base b that will divide into the given number at least once and then divide. 2 will keep the whole number part and multiply the fractional or decimal part by base b. Step 3 will repeat step 2, keeping the whole number part, including zeros, and carry the fractional or decimal part to the next step until a whole number result is obtained. Step 4 will collect all the whole number parts to get the number in base b. Before we take a look at our two examples though, let's see why this method works. If we consider the number 2573 in base 10, notice how the highest power of 10 that would divide at least once into the given number would be 10 to the third, or 1000. So if we take 2573 and divide by 1000, it gives us 2.573. So of course the 2 tells us that we have 2 thousands in 2573, but notice how the decimal part represents the fractional part of 1000 that remains after dividing by 1000. So if we take just the decimal part and multiply by the base of 10, notice how this gives us 5.73, where the 5 tells us how many hundreds remain. This 5 represents 500. If we take this decimal part, multiplied by the base 10, it tells us how many tens remain. There are 7 tens or 70. And then finally the 0.3 times 10 gives us how many ones remain. There are 3 ones. Now let's take a look at our examples. We want to convert the base 10 number 214 to base 3. I think it's always helpful to write out the place values for the given base, which I've already done here below. 3 to the 0, the 1's place value. 3 to the 1 would be the 3's place value. 3 to the second would be the 9's place value, and so on. So to begin, we want to find the highest power of 3 that would divide at least once into 214. Well, notice 3 to the 5th would be too large, so we'll divide by 3 to the 4th, or 81. And because we'll be dividing by 3 to the 4th, notice how our number in base 3 is going to have 1, 2, 3, 4, 5 place values. Let's go ahead and set that up. 1, 2, 3, 4, 5, just so we don't miss any place values. So now we're going to take 214 and divide by 3 to the 4th, or 81. Now we'll take the whole number part, or 2, which will be the digit in the 81's place value. So we'll put a 2 here. And now we're going to subtract the 2, which will leave the decimal part. So minus 2, enter. And now each time we're going to multiply by the base, which in this case would be 3. So times 3, enter. Now we're going to take the whole number part again, or the 1, which will give us the digit into the 3 to the third place value, or 27's place value. So we'll put a 1 here, and now we'll subtract the whole number part, or subtract 1, enter, and then multiply it by the base again. Our base is 3, so times 3, enter. Take the whole number part of 2. That's our next digit for the 3 to the second, or 9's place value. Subtract the whole number of 2, and multiply by 3 again. So times 3, enter. The next digit will be 2, which will be in the 3 to the first, or 3's place value. Subtract the whole number of 2, and multiply by 3 again. Notice how the result is a whole number, so we know we're done. This is the digit in the 1's place value. So what we've discovered is that 214 in base 10 is equal to 21221 in base 3. To check this, let's go ahead and expand 21221 in base 3. This 2 represents 2 times 3 to the fourth. This 1 represents 1 times 3 to the third. This 2 represents 2 times 3 to the second. This 2 represents 2 times 3 to the first. And finally, this 1 represents 1 times 3 to the 0. If we simplify, we do get 214 base 10, verifying our answer. Let's take a look at a second example. We want to convert the base 10 number 13,967 to base 7. Notice to begin, I wrote out the place values for base 7. We're looking for the highest power of 7 that would divide at least once into 13,967, which would be 7 to the fourth. 7 to the fifth would be too large. So because we're dividing by 7 to the fourth to begin, our number in base 7 is going to have 1, 2, 3, 4, 5 place values, or 5 digits. So 1, 2, 3, 4, 5. And now we'll divide. 13,967 divided by 7 to the fourth, or 2,401, gives us this. We take only the whole number part for our first digit, which is 5. And now we'll subtract the whole number part and then multiply by base 7. So minus 5, and then times 7. The next digit is 5, the whole number part. And now we'll subtract 5 and multiply by 7 again. The next digit is also 5. Subtract the whole number part and multiply by 7. Notice here there's no whole number part, and therefore the next digit would be 0. And we multiply by 7 again. This should be the last digit, so this product should be a whole number, which it is. Our last digit is 2. So we have found that 13,967 base 10 is equal to 55502 base 7. And again, just to check this, let's go ahead and expand 55502 in base 7, which I've already done here just to verify that our answer is correct. I hope you found this helpful.